Alright, so in this video we're going to be talking about what about scientific notation to describe really, really small quantities. So, let's get going. Expressing very small numbers in scientific notation really is, again, moving our decimal, and it has to. We still have to abide by the between 1 and 9, so a single digit between 1 and 9, and a power of 10. It's just in this case, when we have smaller numbers and we move 1, 2, 3, 4, I'm going to be 2.34 times 10 to the negative, and how many moves is that again? 1, 2, 3, 4. Negative fourth power. That is how small quantities work, that we are moving our decimal to the right, and it's going to be a negative number. All right, so next problem. Express this in scientific notation. So I know that I'm going to have a 4 times 10, and I'm moving 1, 2, 3, 4, 5, 6, 7. So it's going to be negative 7. Other things that you can do when you're doing these small quantities is when you set yourself up, if you notice that it's a decimal and you're moving to the right, you're going to be negative. And so you can go ahead and put that onto your answer before you get started. All right. Now, what if it wants you to put it into standard form? And so when we move it to standard form, we move decimal to the left. So move decimal to the left. For this one, I go ahead and just leave my number here, and I go 1, 2, 3. That's where my new decimal will go, and I've got 2 zeros to fill in between, and so I end up with 0.00132. And that's how we do it. We just move left, however many our exponent tells us to move to the left. So, example. We have 1.23 times 10 to the negative fifth. Move that decimal 5 places. 1, 2, 3, 4, 5. That's our new decimal. We have 4 zeros, so we end up with 0.1234. 1, 2, 3. And there's our answer. And yes, it's that simple. I'm not trying to trick you. We're going to real quick review ratios, just because some of the problems in this one talk about ratios. Ratios, we read as A to B. A colon B is the same thing. The one we use the most is A over B. So when it talks about ratio, we're setting up a fraction with the first thing stated on top and the second thing stated on bottom. So that's what we're using. So here we have the length of cell A is 8 times 10 to the negative fifth. The length of cell B is that lovely decimal that I'm not even going to try to read. What is the ratio of cell A to cell B? So we've got to put them both in the same. We can't do them differently. So I need A over B. And here are your choices. We can do this one as a decimal would be 0.1234, and then our 8. This one in scientific notation is 4 times 10 to the negative 1, 2, 3, 4, 5, 6. All right, so our options are we can write 0.0008 over 0.000004 and do that division, or we can do 8 times 10 to the negative fifth over 4 times 10 to the negative sixth. And if it was my opinion here, I would feel the need for a calculator to solve. Here I can do 8 divided by 4 times, and then 10 to the negative fifth divided by 10 to the negative sixth. 8 divided by 4 is 2 times, and then 10 we're going to take -5 minus a -6, so that becomes plus a positive. And 6 minus 5 is 1. 6 is bigger, and it's now positive with this expression up here, so it's a positive 1. And so what that is 10 to the first power is 10. So it is a 20-to-1 ratio. This next one says, is it easier to find scientific notation, find in scientific notation or standard form? Like I said, if I do it in scientific notation, I can do most of that in my head. And so I say scientific notation is easier because I can quickly do it in my head, probably faster than I'd be able to type it into the calculator. And that, my dears, is scientific notation for very small quantities. See you in class.